Greetings everyone, welcome back to Tutorio. We're your go-to source for fascinating, easy-to-understand educational content. If you haven't done so yet, hit that subscribe button, give us a thumbs up, and make sure the bell icon is turned on. Doing so ensures you'll always be in the know when we drop another one of our amazing videos. And speaking of amazing, today, we're going to delve into the riveting world of aluminum foil production, so stay tuned. We use aluminum foil in our kitchens every day, but have you ever wondered how it's made? This shiny, flexible sheet we often wrap our leftovers with or use to line our baking trays actually starts its life as raw, unrefined aluminum. It goes through an intricate process to become the handy household staple we know and love. Intrigued? Well, buckle up. We're about to embark on a fascinating journey. Let's dive into the intriguing journey of transforming raw aluminum into thin, versatile aluminum foil. The journey of aluminum foil starts deep underground in bauxite mines. This is where the story begins with bauxite, a reddish-brown clay-like substance that is rich in aluminum ore. It's not something you'd want to make a sculpture with, but it's perfect for making aluminum. After the bauxite is mined, it's transported to processing plants where it undergoes something called the Bayer process. This involves crushing the bauxite and then dissolving it in a hot caustic solution. The aluminum compounds are then separated from the impurities. Once that's done, the solution is cooled, and what's left is a white powder known as alumina. Alumina is essentially aluminum oxide and is the penultimate step in our journey towards making aluminum foil. But we're not quite there yet. There's one more process needed to transform this white powder into the shiny, flexible material we're so familiar with. Once we have alumina, we're ready for the next step, electrolytic reduction. In a process called electrolytic reduction, alumina is transformed into aluminum. Now, this is where things get a bit electrifying. Picture this. We have our alumina, a white powdery substance, which we then dissolve in a molten substance known as cryolite. This creates a bath of molten material that's ready for some electrical magic. Here's where the electrolytic part comes into play. We apply a strong electric current to this bath. The current flows through the molten material, causing a chemical reaction that separates the aluminum from the oxygen in the alumina. This released aluminum then sinks to the bottom of the bath, where it's collected. As you might imagine, this process requires a ton of electricity. But don't worry, all that energy isn't going to waste. It's helping us create the pure, shiny aluminum we all know and love. And now that we have pure aluminum, we're ready to make our foil. The final stage in the making of aluminum foil involves a lot of rolling. Now, let's break this down. Once the purified aluminum has been transformed into blocks, it's time to start the rolling process. The aluminum blocks are first heated to a specific temperature. This is crucial, because the right amount of heat makes the aluminum malleable, allowing it to be shaped without breaking. Imagine trying to flatten a piece of Play-Doh without warming it up in your hands first. It's the same principle. Once heated, the aluminum is then passed through a series of large rollers, sort of like a high-tech pasta machine. These rollers press the aluminum into thin sheets. The more times the sheet is passed through the rollers, the thinner it gets. The aluminum is rolled back and forth until we achieve the desired thinness, but we're not done yet. The final touch in the process is the finishing. This involves cold rolling the aluminum sheets. Cold rolling is done at or near room temperature, which makes the aluminum not only thinner but also stronger. It's a bit like when you knead bread dough. The more you work it, the better the texture. This entire process is carefully monitored to ensure the foil's thickness is just right. Because after all, nobody wants to deal with flimsy foil that tears too easily, right? And there you have it. From a chunk of raw bauxite to the thin, shiny aluminum foil we use every day. So, next time you're wrapping up leftovers, remember the incredible journey that aluminum foil has taken to get to your kitchen. From the mining of bauxite to refining, electrolytic reduction, and finally being rolled into the shiny, thin sheet we use daily, every step is a marvel of modern engineering. Just think, this common household item has a story as complex and fascinating as the food you're preserving. Thank you for tuning in to Tutorio. Don't forget to subscribe, like, and turn on the bell icon for more amazing educational content. Until next time, keep exploring.